Thank you for the introduction. My name is Anna, and I'll talk about interactional coherence comparison between single and multiple chatbots. So we know that chatbots is this this technology with growing popularity. One can find thousands of chatbots available for basically all the instant messaging tools nowadays. For example, over 100,000 chatbots interact through Facebook Messenger every day. So it's a lot, and many of these chatbots intend to help users to solve a task. So these chatbots are basically changing the way people interact with computers to get things done. But however, most of these chatbots, they are designed to perform a very specific task in a very specific domain. For example, in the tourism domain, you can find chatbots that book flights, book hotels, recommend restaurants, recommend places to go, things to do, and many different things. But they don't talk to each other. So it is still a human task to combine the information from all those chatbots to decide what they really want to do. So what we can do to leverage these existing chatbots that perform specific tasks when we want to solve more complex tasks? We are discussing in this paper two solutions for this problem. The first one is to develop meta-chat bots, which is basically a chatbot that have one-to-one conversation with the user, but in background it combines the knowledge from different chatbots. So it's basically assigning just one chatbot to satisfy the user's multiple domain needs. The second approach would be just adapt these chatbots to enable them to perform a multi-party conversation and include them all in the same chat with the user, and they would coordinate their task in order to solve the user's problem. So in this paper, we want to understand how the users perceive these two different approaches. So from the user's perspective, how this conversation would be, what they prefer. And we analyze this conversation from the interactional coherence perspective. Why did we choose this option? Because the interactional coherence helps us to understand if having multiple chatbots in the same chat would be perceived as more disruptive than just having one single chatbot. So the interactional coherence analysis is divided into two aspects, which is turn-taking. Basically, we want to understand whether having multiple chatbots would be more disruptive in terms of how the users organize the conversation. And for sequential coherence, we want to understand if they would change topics more frequently or overlap topics more frequently than having just one chatbot in the same conversation. So we simulated these two scenarios using a Wizard of Oz experiment. We invited 24 participants to talk to a chatbot that understands three different domains, which is shopping, nature, and cultural activities. So all the three chatbots talk about things to do in a specific tourist destination. But in the first scenario, we're simulating the single chatbot scenario. We're simulating this meta-chat bot. So we have three wizards, but just one of them was answering the user's requests. And in the second scenario, we had the same three wizards and the same databases, but they were in a group chat, and all of them were answering the questions. The important thing to understand here is that the wizards had the same behavior in both scenarios. same database, the same. When we have a specific request that 3 of them could answer fairly answer in the multi-chatbot scenario, then in the single chatbot scenario, the user would receive the same 3 answers, because we just want to know, measure how disrupted the conversation would be, just having more agents in the conversation and not changing the conversation structure itself. So for turn taking, our first question was, does the multiplicity of chatbots as interlocutors influence how people organize turn taking? To analyze that, we observed how users behaved when the chatbots started to answer the questions. So as you can see in the image in the right side, the left side, we have tourists asking for hotspots, or in the right side we have asking for popular places. Because the 3 chatbots knows about things to do, both of them could, in both scenarios, all of them could answer this question. So in the single scenario, the same chatbot answered with 3 different options, and the user saw it as options. Choose one and move on. In the second scenario, the multi-chatbot scenario, they received the user received the same 3 options, but they didn't see it as options. They see it as many different agents talking to me, and they get confused. So who should I talk to? What should I say first? Who I should answer? And they started trying to find ways to better organize the conversation. So it's basically the same conversation, but the users was reported to be more confused when they were talking to multiple chatbots in the same chat. For the second research question, still about turn taking, we observed whether the multiplicity of chatbots would take the users to change topics more frequently. In this case, we have a limitation about Wizard of Oz experiment. It was humans, right? So they had to read the sentence, go to the database, copy the appropriate answer, paste in the chat. Participants in the single chatbot scenario complained about response time. They submit the answer and expected the chatbot to answer immediately. When it doesn't occur, they started to think that the chatbot crashed or something like that. But just in the single chatbot scenario, users complained about that, and not in the multi-chatbot scenarios. But in both scenarios, the user behavior was wait. So they did not start another thread, they did not send another message, they just wait. So we could not find a significant difference between the 2 scenarios about topic overlap. And for the third question, which is about sequential coherence, we are observing when we have 3 different chatbots that talks about 3 different domains, 3 different knowledge, talking to the user in the same conversation, maybe this will lead the user to change topics a couple times. What happened for both scenarios was that we had a lot of messages ignored. So as you can see in the first table, we have 65% of the messages were ignored in the single chatbot interaction and 72% for multiple chatbots interaction. And a message ignored is basically a message that the user did not reply. It just replied to another message or started another thread, but did not really talk about that specific message. So we marked it as ignored. Why we believe that many messages were ignored in the conversation? Because as you saw in the previous example, we had 3 chatbots answering, one about shopping, one about culture, one about nature, and maybe the user won't talk about nature, so the user will ignore the other messages, right? So we want to know if this is really disruptive. We tried to observe in the more specifically if this was really related to the fact that we have multiple chatbots, or if this is related about the user's interest in a specific topic. So we observed why the users ignored the messages. And we found 2 different outcomes. The first one was that the message was useless because the user has talked about that topic before and probably had enough information. So when the chatbot started talking, for example, about nature again, then the user just ignored. And the second is that the user was in the middle of a conversation about, for example, shopping. And then the chatbot, the nature chatbot, sent a message and the user ignored because, it's in the middle of a conversation about shopping and don't want to change the topic. So that wasn't the most appropriate time to insert a new topic. So what we found is seed messages or the messages introducing a new topic in a new domain are actually disruptive. But the other thing we observed is that sometimes when the user saw a message about a specific topic, they get inspired to ask about this later on in the conversation. So those, what we called seed messages, helped the user to actually understand chatbot's knowledge, which is important as well. So the way we inserted new topics was disruptive, but we believe that we should find a better way to introduce new topics because it actually helped to convey the chatbot's knowledge to the users. When we are trying to answer those questions and reading our data, we actually found some other important findings. First thing was that a couple users, you saw the messages, it was quite long, and a couple users complained about having to read all those textual information. So the long messages are annoying from the user's perspective. And sometimes the user stated a decision, for example, okay, I want to go to the museum, and then the chatbot keep talking. So maybe the chatbot should know when to stop talking about a specific topic, even if the user did not provide a explicitly closing for the conversation. Some of our users talked to the chatbot in a very polite way, and some of them just sent some keywords like, I want to talk about food, I want to talk about museum, I want to talk about. So this might be related to the way the users perceive the chatbot and the role it's performing in the conversation. And finally, the language complexity. Some users want to ask several different topics in the same sentence or ask for comparison. For example, the best restaurant or the most popular place to go, and these are decisions that is hard to be done by a chatbot. So our main takeaway message here is that although the conversation, the structure of the conversation was the same in both scenarios, participants reported different communication experience. But both scenarios showed to be feasible solution in terms of coherence. They were quite similar. However, if you're developing a multi-chatbot scenario, you should establish a specific turn-taking protocol to give the chance to talk to all the participants in the conversation. And then we saw that the strategies to minimize the amount of disruptive messages are important, and you still have to have ways to convey chatbots' knowledge when they are talking in a complex domain task. Quickly, I would like to say that our next steps in my research is studying language variation for chatbots and how it influences the way chatbots are seen as social agents in a conversation. So I'd be more than glad to talk about this topic as well later on with you if that might interest you. Thank you, and I'll be more than happy to take any questions.
Thanks. Please line up for questions.
Thank you for your talk. You're sitting on top of an area right now that is white hot, as you probably know. In fact, there's this contest that takes place usually in December called the Dialogue Systems Technology Challenge, the DSTC. And there was actually a paper at last year's DSTC where they were talking about errors that neural network-driven dialogue systems typically make. And among the foremost errors were ones that you directly pointed to in your other findings, where they would quit before the goal had been accomplished, or they would just try to keep the conversation going after the goal had been accomplished. Or they would just start profusely expressing gratitude for no reason. So I think it would be really interesting for you to go into that literature and see how maybe you can speak to that particular community of engineers, because they obviously need to hear this.
Great. Thank you so much.
Hi, thank you. Steve Whitaker from UCSC. So can you just go back to your previous slide? So this is kind of, again, related to the engineering question. So if you do want to have a choice between multiple possibilities, how would you do that algorithmically? So you've seen the need to do that. So how would you do that based off the kind of data you're getting?
Are you asking about how we should decide what chatbot would answer?
Yes, so you've identified a need now to kind of not have too many competing topics.
Yeah.
So algorithmically, how would you make that decision?
Well, the chatbot's development has some confidence level that defines if the chatbot has the knowledge to answer that question or not. What we're simulating here and what we believe it would work for coordinating multiple chatbots would be, well, if you're confident that you may answer the question, then you should answer, even if other bot can also answer the question. So it would be based on how confident the chatbots are.
Yeah, sorry, but I noticed you're not using context there, which is another thing that you've referred to.
Yeah,
so that might, you might actually go knowledge or context.
Yeah, they must understand the context. That's true.
Shamsi Iqbal, Microsoft Research. Thanks for the talk. This was very interesting. So I had a question about kind of the chatbots talking to each other or building on each other's knowledge. You mentioned that sometimes the messages were ignored because either they had been answered before or the user chose to focus on one message. I wonder if you have thought about if one of the chatbots or the other chatbots would build off what the first one had suggested. So, for example, if it's about something about shopping, and then there's a nature chatbot that would say that, by the way, there's something around nature closer to the place where. Yeah. Have you thought about that?
Yeah, this basically the strategy that we used. So they're talking about shopping, and then they said, well, the shopping is located in this place, and then the nature said, this place is close to a national park. then introduce the topic in the conversation. So this is, they were allowed to read messages both from the user and from the other chatbots in the conversation, and they select the answer basing on keywords, right? So if they saw a keyword that is related to their database, then they answered. And this is why we had this amount of ignored messages, because they said, okay, but I still want to talk about shopping. I don't want to move to the national park maybe yet. Maybe the user called back, okay, about that national park, and that happened. So this is why I told that we should consider using this as a way to convey features, but maybe not when the conversation is still taking place.
So one follow-up point. So you mentioned ignored, and I would almost argue that in some cases it's maybe not ignored. So if there's a way of acknowledging that I have acknowledged this and not necessarily ignoring.
Thank you.
Yeah, I was thinking of that. So my question is related. I'm Anouk from UCL. I was thinking, are there any social implications that maybe you want to please all of the chatbots and you don't just want to ignore like 3 of them?
Yeah. That's why we believe that several users in the multi-chatbot scenario complained about being confused. So they said things aloud. We invited them to think aloud. And several times they said, who should I answer? Who should I talk to? And, it was the same conversation as the single users were having, and they were not complaining. So we believe that there is a division of attention because there are more agents. So definitely there is a psychological, social implication in this finding.
Hello, I'm Eloisa from IBM Research, Brazil. So I would like to know more about the methodology, because you had like one wizard in one side, and the other side you had 3 wizards, right?
No, it was the same 3 wizards. But the wizards were in the same room, 3 of them, and each of them studied their single database. So each of them had their own database. And it was the same one in both scenarios, the same person. The only difference was that in the single chatbot scenario, just one profile, Facebook profile, was being used to paste the messages. So just one person was copying and pasting to the single interface that they have. But it was the same person behind the scenes saying, oh, this is the right answer, and that is the right answer for this. You should, so it was the same ones. And we used the same person to control this, the difference that might be if just one person had all the knowledge, it would be quite different. So we use the same ones.
Yes, and about the neutrality, because you compared single and you compared multibots. So how do you know? Because sometimes you can't predict what people is going to ask. So how do you know that you always had the same cases in single and multi? How did you manage that?
Yeah, we didn't control the task. So we told the users, well, you're going to travel to this specific place, find something to do. And they could ask whatever they want. A couple users just sent several characters, and submit just to see what the bots would do. So we didn't control that. The bot said, I don't know what you're talking about, or I don't have the answer, and they have a template message to say sorry, so they could not adapt the answers. They should just go to their database, copy and paste appropriate answers if they have one.
Okay, and it was the same user, like evaluating both?
No.
You had
12 users each scenario.
Okay. Thank you very much.
Thank you.
If you have more questions, I encourage you to stay and talk to the speakers. Otherwise, let's thank our speakers again and enjoy your lunch.